Well, thanks everybody and welcome. Thanks for joining us this evening for this webinar, which is part of the Engineering National Development webinar series run by the West Region. Tonight's event is on high quality international connectivity, and we have two great speakers here with us. Andrew Murphy is Director of on Aviation with Transport and Environment, who he joined in 2014, having previously worked for the Green European Foundation and at the European Commission's Transport Directorate. Andrew is from Galway and has a degree in political science and law and a Bachelor of Law from NUIG. Since 2021, he is also a member of Ireland's Climate Change Advisory Council. Andrew leads Transport and Environment's work on sustainable aviation, which includes pricing mechanisms, new fuels, and finally addressing aviation's substantial non-CO2 climate effects. And then Kieran French is an electrical engineer with 15 years experience in the energy industry. His present role is technical lead for Eirgrid on the Celtic Interconnector project, which we'll be talking about this evening. And he's responsible for developing all engineering aspects of the proposed HVDC interconnector to France. So I'll hand over to Andrew, who's presenting first, and thanks.
Great, thanks so much for that introduction, and thanks for the invitation to speak at today's event. There we go, it works. As introduction said, I represent Transport Environment. I've led our aviation work. In reading out my bio, I've been exposed as not an engineer. My background is from the policy side, the legal side. A little bit about Transport and Environment. As the name suggests, we're a European level NGO focusing on promoting sustainable transport in Europe. We work with different members across Europe. Onshore is our Irish member, for example. We've been around now for over 30 years. We first were set up with a focus on car standards, in particular air pollution. We work a lot on electrification of road transport. We work a lot on different fuels, alternative fuels. We work a lot on heavy goods vehicles. And I lead the work on aviation and have done so for 8 years. And it is one of the more challenging aspects of our work, certainly one which is quite interesting. So, next slide. So, yeah, some of our member organizations. So let's focus on aviation. That's where I work. I joined TNE in 2014. As you can see, that's right around the time aviation emissions took off in comparison to other sectors. So the yellow line there is the growth in aviation emissions, which has been pretty impressive since 1990. And you can see some of the other sectors whose emissions have gone down during that period. When talking about aviation emissions, oftentimes the phrase used is aviation is a difficult to decarbonize sector. And what we say in response to that is any sector is difficult to decarbonize. If you look at the home heating system sector, there are solutions, but it's quite difficult to deploy them into everyone's house and to get individual consumers. There are solutions to reducing the climate impact of agriculture. Generally involves eating less meat and drinking less milk, but that's also quite difficult as well. So at TNE, we don't really accept the label of aviation as a difficult to decarbonize sector. The growth in emissions which have occurred, particularly since 2014, are the result of the fact that we haven't put in place the sort of effective measures that are reducing emissions in other parts of the economy, such as binding targets, more effective carbon pricing. All that has been left on the table. That aviation is sometimes referred to as international aviation and international sector. Again, that's sometimes used as kind of an excuse. It belongs to the international community and needs to be regulated through UN agencies. That's a nice way of avoiding more effective national and European measures, and ignores the fact that a lot of sectors are international. Volkswagen exports to 160 countries around the world, very international, yet we have binding car CO2 standards. Let's continue by stating the obvious. Ireland is an island. You don't need to be an engineer to know that. We are incredibly reliant on our aviation and shipping industries to get people and goods on and off the island. We are an incredibly exposed global island in that we are incredibly reliant on importing food from abroad. The structure of our economy relies on getting people on and off the island. be it for connecting multinational companies, be it for tourism. And we're seeing Ireland's vulnerability in the discussion now around, for example, food imports, which are going to be enormously affected by the conflict in Ukraine. We've set up a particular structure which involves us producing a lot of infant formula and powdered milk and sending it around the world, and then importing lots of food to actually feed ourselves. That means how we get goods and people on and off the island is incredibly important, and a lot of consideration needs to be given to how we can do it sustainably and how we can maintain it in the years going forward and make sure those sectors decarbonize like other sectors. But at present, and aviation is the area I know best, so it's one I'll draw on a lot, but 95% of what I say about aviation is also relevant to shipping, in terms of some of the solutions, in terms of the government's position, in terms of its importance for Ireland. So it's not something we can just ignore. And the reality is both aviation and shipping are at present 100% reliant on fossil fuels. I think for aviation, it's 99.95. My shipping colleague tells me for shipping, it's about 99.1% dependent on fossil fuels. So these sectors at present consume enormous of fossil fuels. They don't have sort of low carbon technology that's accelerating in the heating sectors, in the road transport sectors, the electricity sectors. So what are some of the solutions? Yesterday, TNE released its roadmap to climate neutral aviation in Europe. And on the right, we outline what some of the solutions to decarbonizing aviation will be. And it's not a demand management versus techno solution, as sometimes when you have a climate discussion, sometimes the discussion is, well, should we consume less or should we decarbonize? For aviation, it's a bit of both. There are technical solutions, fuels, which I'll go into in more detail, but there is no technical solution on the table tomorrow. There's no zero emission aircraft, even though they grace the cover of this report. They don't actually exist in reality. There are a few test flights, Pipistrel and Heart Aviation, which are experimenting with 2 or 3 seater electric aircraft, and I'll happily discuss some of the barriers to zero emission aircraft. It's an exciting area. It's technically possible, but doing so in a way which is financially viable and respectful of safety. The huge level of safety in the aviation sector is very challenging. And fuels are a solution as well, as I'll discuss in the next slide. But if we look at the most recent IPCC reports just last week, if we look at what the climate targets are, they all require a drastic reduction in the combustion of fossil fuel. And any sector that is 100% reliant on fossil fuel needs to drastically reduce. And that presents problems for Ireland, where it's not easy to substitute for rail, as some other countries would do. It's not easy for Ireland with shipping, where we're so dependent on importing food from overseas and exporting our food to foreign markets. So which fuels? I'll happily discuss this in more detail because it's an interesting discussion. A drop-in fuel is the most effective way to reduce emissions from aviation. A drop-in alternative fossil fuel, because as I said, zero-emission aircraft powered by something else than liquid fuels are many years away, and aircraft themselves have a life cycle of 20-25 years. So Boeing and Airbus have constructed a very large fleet of jet-powered aircraft. They are constructing more and more of them in Seattle and Toulouse. So our best bet really is developing an alternative to fossil fuels. So what can you put in an aircraft that will be an alternative to fossil fuels? There is crop-based biofuels produced using ethanol or produced using any sort of crops grown on land that could also be used for food. That was problematic a few months ago because expanding crop-based biofuels would drive up the price of fuel. It can drive deforestation by displacing food consumption. It's extraordinarily problematic to in any way increase crop-based biofuels at the present, given the enormous shock to our food system that the invasion of Ukraine has posed. So crop-based biofuels have gone from a bad idea to a terrible idea in the space of a few weeks. There are advanced biofuels. This is kind of the next generation of biofuels, which don't compete with food, but take some of the products which are byproducts of the agricultural system, byproducts of the forestry, and turn them into a biofuel which can be put into an aircraft. And so they don't compete as much as with food. The unfortunate thing is for a lot of these feedstocks, they're already kind of been used for something else. if something has an energy content that can be relatively easily transferred or turned into a sustainable fuel, it's not particularly easy to, they're not lying around waiting to be used by the aviation sector. One example of this is animal fats, for example, in some Asian countries. So there's an idea that we'll take animal fats, they're not being used. Sometimes those animal fats are being used. Sometimes they're being used in the oleochemical industry. Sometimes they're being used for pet food. So if you put them in aircraft instead, well, then the cats and dogs will go hungry or they'll eat something else. And again, you have displacement effects. Rather than shifting the energy source, an existing energy source, around from sector to sector, what you generally need to do is produce a new energy source and produce a fuel based on something new. On the right, you see the basic idea of electrofuels, which is a type of drop-in fuel produced through a combination of hydrogen, and that hydrogen should be green hydrogen produced using renewable, ideally additional renewable electricity, combined with CO2 so that the chemical property resembles a fossil fuel, but in the CO2 being pulled out of the atmosphere, the hydrogen can be produced using renewable electricity. Essentially, you don't have a negative climate impact. You combust this electrofuel in the atmosphere, so you do emit CO2 into the atmosphere, but it's CO2 that you capture again to continue the production of the fuel. And what it does is it disrupts the greatest cause of climate change, which is extracting the fossil fuels out of the earth and putting it into the atmosphere. The problem is, as many of you know, production of green hydrogen is incredibly inefficient. If you have 1 unit of renewable electricity, turning it into an e-fuel through the process of electrolysis, through the process of capturing CO2, you actually lose a huge amount of electricity. It's why, for example, hydrogen in the road transport sector isn't really taking off as a viable option. It's better to plug the car in directly. It's why green hydrogen for heating isn't taking off as an idea, because it's better to install a heat pump. If we could plug in an aircraft, we would. Alas, we're left to work with the existing infrastructure of creating a new drop-in fuel, and that production is incredibly inefficient. So some of the modeling we've done, and it's in the roadmap we just released yesterday, given projected aviation demand out of 2050 and projected renewable electricity production, we may have to set aside or use 1/4 of all renewable electricity in Europe to produce the e-fuels needed to power European aviation. If you go down the route of demand management, it's a mere 12.5, still quite a lot, but it shows the importance of integrating demand management and also properly forecasting how much electricity you're going to need in 2040, 2050, so you can start doing the planning now. Maybe that green bar on the left, that needs to be bigger if we take into account the demands that come from aviation shipping. And the solution for shipping is similar. It's possible to produce different types of fuels, such as ammonia from adding nitrogen to hydrogen, and that requires some changes to the engines. But ultimately, like with aviation, you don't want to take existing biostocks of energy. You want to use renewable electricity to produce hydrogen and power the ship directly, produce ammonia for a new fuel. And some of these e-fuels, some of these types of fuels, they aren't new in reality. Actually, the last time we were using ammonia was I'm told it was Belgian public transport during the Second World War as a substitute for the shortages of fossil fuels. Actually, and it's a very interesting story. The production of e-fuels for the economy first began as concept in the 1930s when the German government, which came to power in 1933, wanted to move towards more self-sufficiency and brought about, tried to seek how to produce petrol domestically, and mandated and instructed German coal companies to start using coal as the basis for the production of a petrol alternative. And there's a big history about this. Japan also faced shortages of fossil fuel domestically. So they looked at actually producing themselves through a similar method. They realized it was too energy intensive, required too much labor. So they went for the easier path of declaring war on the US. So that gives you some idea of how difficult it is to actually produce these fuels. So these fuels are a potential solution for aviation, but they are a challenge. They require a lot of investment. They require a lot of planning. 2050, when we're supposed to be at net zero, is only 29 years away. Not that far away. It's fewer years than I've lived on this earth. So, the question is, are we actually planning for this as a solution to aviation? And the question kind of is no. So what's the Irish government doing? On the left, you see a big consultancy group, which is committed to flying less in order to attract climate conscious employees, in order to reduce its carbon footprint, maybe also in order to reduce its total bill. And a lot of companies in the last year or two have recognized from COVID that actually, they don't need to physically fly their employees around at the different parts of the world. It's quite inefficient. It's quite a drain on the actual individuals themselves. Yes, flying for work can be a pleasure sometimes, but not always. Now, in response to some of this falling demand, and you can look at many of the multinational companies which are based in Dublin, and I can point you to some of the commitments they've also made to reduce flying. The Irish government, in response to this reduction in demand, have decided to spend €90 million basically subsidizing demand for a form of transport which is 100% dependent on fossil fuels. The Irish government doesn't particularly want to see that actually maybe people are flying less for climate reasons, maybe companies are reconsidering there's a lot of people, Irish people who for leisure travel benefit a lot from that corporate connectivity. Talking to one individual in Ireland yesterday, a few weeks ago, he has family in Minnesota. There's a big pharmaceutical connection. So, the pharmaceutical companies would fill up the business class and he'd, tag along for basically break even in the back to visit his family in Minnesota. So we all benefit from corporate travel, but it's not coming back. And there's better things we can do with €90 million when it comes to decarbonizing our economy. So what exactly is the Irish government doing to make sure we develop these fuels, which are so essential to Ireland's ability to remain connected in a decarbonized way from 2030, 2040 onwards? On the left, you have the Climate Action Plan, which was released last November, I think. And here you have it. It's the Irish government saying these sectors are crucial to our economy. We will rely on the international and European measures to make sure they are decarbonized. That's a slightly absurd position because there's EU rules on things like cars, there's EU rules on things like energy efficiency of buildings. But of course, the Irish government has taken the position that EU rules aren't good enough. EU rules alone aren't good enough just for cars. EU rules alone aren't good enough for decarbonizing buildings. So it's put in place targets for vehicles. It's put in place targets for retrofitting buildings. It's putting money aside to make sure they're supported. It's not doing likewise for sectors like aviation and shipping. It's simply outsourcing the job to the EU, and even worse, to an organization known as the International Civil Aviation Organization, which is the UN Aviation Agency, a fine organization for promoting aviation safety, a terrible organization for promoting the decarbonization of aviation, having done little since it was asked to address this issue by the Kyoto Protocol 24 years ago. On the bottom right, you see the National Development Plan, which was from August last year, I think. It talks a bit about this, about developing these kind of fuels in Ireland, but there's not actually much planned already. What should the Irish government be doing? Ireland is one of the few countries in Europe not to have adopted a hydrogen strategy to decide how to ramp up hydrogen production, what sectors to then put it in. What a good hydrogen strategy would say is we need a lot of green hydrogen in Ireland, largely for aviation and shipping and a few other sectors for balancing out the grid. We don't have a hydrogen strategy. That's, our huge shortcoming. It's something which needs to be rectified. We don't have a clear position on the EU's Fit for 55 legislation. So the EU is proposing a raft of measures around these sectors. It's proposing a pretty weak target for alternative fuels in aviation. It's proposing a target of 0.7% for e-fuels in aviation. We're yet to adopt a clear position on that. So the idea of, well, we'll support European measures, would not be particularly supportive of European measures. If we were, we'd be going to Brussels asking for more ambition in this area, for championing higher targets, greater production. We're not doing that. We're quite quiet. And we would support domestic production. We would identify the huge opportunities on the West Coast to install renewables, electrolyzers, scale up this production. We can't do it immediately. When new electricity comes online in the next few years, it should ideally be squeezing out the coal plants that we're unfortunately still using to generate electricity at the moment, owing to the crisis. So we're not doing a lot. What should we be doing? UK last April decided to include aviation and shipping within their carbon budgets. And that's sort of the essential starting point for doing anything. why would you spend money? Why would you spend effort reducing emissions from a sector that you pretend aren't part of your own climate targets? If it's not in the targets, it doesn't get addressed. And on the right, the German government has introduced its own domestic policies to support e-fuels. It recognizes them as hugely important. It's giving money. Government agencies are working on it. Industries are cooperating. That's the kind of action we should be seeing from the Irish government to make sure that these sectors are covered. So what does Ireland need to do? One, develop a hydrogen strategy with a focus on e-fuels, include aviation and shipping in carbon budgets, the drafting of the legislation, the Climate Change Act, and some of the secondary legislation limited the ability for the Climate Change Advisory Council to include it, and then finally remove some of the subsidies to the aviation industry. And generally recognize that the aviation industry, and from in Brussels, and T&E will have an expose on this in a few weeks' time, the aviation industry, in particular Aer Lingus as a member of the International Airlines Group, are not very progressive on these issues. In fact, a lot of lobbying is around making them weaker. That's because, not to sound like sort of a raving communist, the interests of the International Airline Group are to return to profitability as quickly as possible to minimize regulation. The interests of IAG are different from the interests of Ireland. The interest of Ireland and the point of having a government is to focus on the long-term sustainability, financial viability, connectivity of Ireland. Our concern is to make sure we can get on and off the island in years to come in a sustainable manner. It's not the same interest as industry, which is to return to profitability as quickly as possible. And the Irish government needs to put a bit of distance between what industry is telling them to do and what's in the best interests of everyone who lives on this island and everyone who doesn't live on this island but likes to come home occasionally to visit his family. So that's my main presentation, and I'll hand over to the other speaker.
Thanks, Andrew. Very informative. A lot of things there that I wasn't aware of. So I'll briefly introduce myself, and I'll just start sharing my slides here as well. Okay. Hopefully that's all coming through. So my name is Kieran French, and I'm the Eirgrid technical lead for the Celtic Interconnector project. And this evening, what I'd like to do is just to discuss what exactly is the Celtic Interconnector, what it entails, why it's being developed, and run through some of the objectives and benefits that its completion is going to bring. I'll take a few slides to discuss some of the technology that we're going to use, and I'll focus in on the converter station technology, but also the submarine and the land cable technology as well. I'll give a little bit of a brief overview of some of the marine survey work that we've undertaken in developing the project, and I'll also then finish with a status of where the project is at this point in time. So what exactly is the Celtic Interconnector? It's a planned HVDC interconnector to link the Irish electricity system to France and consequently to mainland Europe. So we are electrically isolated here on the western edge of Europe. So this is a vital interconnector for the energy use here in Ireland. So it's planned to run from East Cork to Brittany on the northwest coast of France. It's a joint development between Eirgrid, who are the TSO here in Ireland, and RTE, Réseau de Transport d'Électricité in France. So as I said, it'll be the first electrical interconnection between Ireland and France, and the first from Ireland to mainland Europe. The project has gained significant status and notoriety, let's say, in terms of its development. It's noted in the ENTSO-E European 10-year Network Development Plan, which assesses electricity transmission network projects on an EU-wide basis. It's also been designated as a project of common interest, or a PCI project, since 2013, which means that it's been identified as a key infrastructure project required to integrate European electricity markets. It also has the title of an electrical highway under the eHighway 2050 projects, and this identifies the project as part of the developments on the European grid needed to meet the EU's 2050 low carbon economy goals. And it's one of the very few projects that has achieved this double labeling. So RTE and Eirgrid have been studying the feasibility of the interconnector since 2011, over 10 years now, and we've been developing it under various cost-sharing agreements since 2014. Just a brief slide here on Eirgrid, who we are. Eirgrid is the transmission system operator responsible for the safe, secure, reliable supply of electricity across the island of Ireland. So we manage and we operate the electricity transmission grid. Under our license, we're mandated to explore and develop opportunities to interconnect the system with other systems. And an example of this would be the existing East-West Interconnector, which goes between Woodland and Meath and Shotton in Wales. RTE then are the equivalent in France. They're the TSO in France, and they are responsible for the operation, maintenance, and development of the system there. So as you can imagine, it's quite a larger system in France than it is in Ireland, 105,000 kilometers of power lines and 2,700 substations. They are also more widely interconnected with their neighbours in Europe and have existing interconnection with Belgium, Great Britain, Italy, Spain, and Switzerland, with some other interconnections in development alongside the Celtic project. In terms of the technical parameters then of the Celtic Interconnector, it will be approximately 575 kilometers in length, and it will link the Knockgraha 220 kV substation in East Cork to the La Martyre 400 kV substation in Brittany. 500 kilometers of that will be in the offshore area, and then we will have 35 kilometers of land cable in Ireland and 40 kilometers in France. The interconnector will have a power transmission capacity of 700 megawatts, and this was set based on studies and analysis of the network strengths both in Ireland and in France. In Ireland, our largest single infeed or outflow at the moment is that of the East-West Interconnector, or EWIC, which is 500 megawatts. And we undertook engineering studies on a range of factors, including the operational requirements and the characteristics of the Irish system, to determine what a suitable capacity level would be for the Celtic Interconnector. One of these would be the avoidance of large grid reinforcements or operational changes. And the studies concluded that 700 megawatts would be feasible without major investment to the existing transmission grid. And this was also confirmed through the similar studies in France. The AC voltages then to connect the grids will be 400 kV in Ireland and 400 kV in France. And the DC voltage of the interconnector portion will be 320 kV, which could be considered almost an industry standard for a power transfer capacity of 700 megawatts to 1,000 megawatts. In terms of the technology then, VSC or voltage source converter technology was identified as the preferred solution based on the low short circuit ratios at the Irish and French transmission system connection points. VSC schemes can operate in completely passive systems with no generation, zero fault level, and or zero short circuit ratios. VSC schemes can also provide good advantages or required characteristics, let's say, to optimize the benefits for Ireland and France. We can get voltage support for the regions, we can provide black star capability, and we can provide frequency response to faults on both systems. The VSC technology that's been chosen will be in what's known as a single terminal symmetrical monopole configuration. We're also looking at laying fiber optic cable alongside the power cable, and this would be primarily to provide communication between the two converter stations in Ireland and France, with potential for further communication also. So why are we doing this interconnection? Firstly, it's a mandate for Eirgrid as TSO to explore and to develop opportunities for further interconnection. An interconnector economic feasibility report was published in 2009, which identified where the opportunities for further interconnection would be. And the interconnection with France has been included in the TSO system development plan since 2012. The project is of national strategic importance to both Ireland and France, and it will allow Ireland directly contribute to and be part of the energy union, and it will reduce our electrical isolation. As I said, we are electrically isolated on the edge of Europe with a single connection into the UK through EWIC. So we have low levels of electrical interconnection, and it's presently consists of 950 megawatts. So 450 megawatts via the Moyle interconnector between Northern Ireland and Great Britain. And as I say, the 500 megawatts through the East-West interconnector between Ireland and Great Britain. So we're currently below the EU electricity interconnection targets of 10% for 2020, 15% by 2030. And with the UK leaving the European Union, we'll have 0% interconnection with European countries. So we're triggering all three of the European Commission's thresholds, which are designed to identify the need for urgent development of interconnection. We have a yearly price difference of greater than €2 per megawatt hour between countries or regions. We're below, our interconnection capacity is below 30% of our peak load, and our interconnection capacity is below 30% of installed renewable generation. In terms of the objectives and the benefits of the project, then there's three main ones that I'll touch on this evening. First one is improving market integration. So we're going to connect the single electricity market here in Ireland to the French electricity market, and consequently into the EU internal energy market. So in doing so, we're going to facilitate increased electricity trading, resulting in downward pressure on the cost of electricity to consumers. Price differentials between the markets are significant. Ireland's wholesale electricity prices on average were €13 per megawatt hour, or 26% higher than France in 2018, and 19% higher than the EU average. The SEM, the single electricity market in Ireland, has recently completed a major transformation to comply with the European target model for electricity, and the interconnector would ensure Irish consumers benefit from this transformation. We will also increase the competition in the energy capacity and ancillary services markets, which will improve the market outcomes and value for the customer. The second objective and benefit then is to enhance the security of supply. We will do this effectively by adding an additional supply of power and increased diversification of energy sources. So it will enable the pooling of the risk of load shedding between the countries, between Ireland and France. And the interconnector will provide black start capability and flexibility services, as I said, for frequency and voltage support. The benefits not only lie here to Ireland, who are electrically isolated, but there are benefits for France also. It will contribute to the security of supply during peak hours in France, but also in any other contingency situations where adequacy is at risk. The third benefit then is the increase in the RESI, or the renewable energy sources from electricity. So Ireland is one of the largest renewable capacities in Europe, particularly with respect to the onshore and the offshore wind. Without the Celtic Interconnector, Ireland will face difficulties facilitating the utilization of this resource. So the interconnector will allow the efficient utilization of the Irish wind energy potential. And it will do this by reducing the curtailment and the need for subsidies to support the RESI development. And it will also allow us to export RESI from Ireland to the larger markets. The interconnector would then also be a key enabler of the Irish government policy. And it's presented in the Ireland, sorry, I'm just looking down at my notes here. It has been presented in the Ireland's draft National Energy and Climate Plan, as recently announced, of having 70% RESI by 2030. So as I said earlier, we've been developing the project with our counterparts in France since 2011. and under various cost sharing agreements since 2014. And we've done this in various phases. Pre-feasibility, which ran from 2011 to 2014, which looked at potential benefits, the types of technology, and the likely costs. We then moved into the feasibility stage between 2014 and 2016, where we undertook some marine surveys. We looked to finalize some of the project parameters, and we did some analysis of the economic and financial aspects. 2016 to 2019 then was the IDPC, or the initial design and pre-consultation, where we further developed the electrical parameters and the initial design requirements. We undertook pre-consultation as part of the consenting process. We submitted investment requests to the national regulatory authorities, both in Ireland and France, and we submitted a grant application to the EU for funding. So we're presently in what's known as the consents, contracting, and construction phase, whereby we have submitted our consents application. We're mid-process in terms of EPC procurement, and following the completion of that EPC procurement process, we'll move into the design, manufacturing, construction, and energization phase of the project. I just mentioned there that we applied for some funding from the EU. So we did this through the Connecting Europe facility. It's an EU funding instrument to promote growth, jobs, competitiveness through targeted infrastructure. And in October 2019, the project was awarded almost 531 million under this facility. There's an agreement then in terms of how the remaining costs are going to be split between the two TSOs. And the regulators have agreed cross-border cost allocations in terms of where the benefits lie and where the costs and the financial support would need to be. So we are looking at a project in over the 900 up to 1 million, up to 1 billion in terms of scale of capex. So it is quite a significant investment. Briefly, just to touch on some of the technology that is going to be implemented here. We'll look specifically first at the HVDC technology for the converter stations. And what do we mean about HVDC? Basically, in the simple terms, it's a point-to-point transmission of power, whereby we convert the AC power from the electricity grids in Ireland and France to DC. And that's done at a converter station, a rectifier converter station, transmit the power at DC to the other end of the link, where it's inverted at the other converter station back to AC. Under HVDC schemes, power can change direction. We can send power from Ireland to France, or the power can be sent from France to Ireland. So it's bi-directional. And the inverter and the rectifier converter stations, as shown there, can alternate in terms of their responsibilities. There's two forms of technology per se in HVDC. You have line commutated converter, where the thyristors are used to commutate the current. And we have voltage source converters, which we're going to implement for the Celtic, which are self-commutating, where we have IGBTs, which are switches basically. They're switched on and off by a control system to enable the development of the DC and the AC voltage waveforms. The IGBT valves in VSCs, they allow for independent control of active and reactive power. There's no limitation in terms of short circuit capacity, and this allows the black start functionality. The transformers that are used in VSC schemes are similar to AC standard transformers per se. They're not exposed to huge DC stresses like LCC transformers would need to be. We have compact design in VSC. We have minimization of filters and reactive compensation. And the reversal of power is far more efficient, can be done instantaneously in a VSC scheme as opposed to LCC. Just a brief overview of the cable technology. I've got some examples here on the slide. The image on the right are actually the cables that are used on EWIC. The conductor shown here can be copper and or aluminium. It will really depend on the manufacturer proposal when they're bidding for the work, whether they wish to propose copper or aluminium in terms of their solution. If we just look at the image on the right, the copper cable there, the one with the green stripe running down through it, is actually the submarine cable for EWIC, and the submarine cable would have some significant armoring or mechanical protection on it, as opposed to the land cables, which are shown there as aluminium cables. So the cable manufacturing for Celtic, we're looking at 575 kilometers in total. There's 2 cables involved in the DC. So instantly there you're into the region of almost 1,000 kilometers of DC cable, and then the AC cables for the 40 kilometers on the French side and the 35 kilometers on the Irish side. There's 3 cables involved there. It's a 3-phase system. So there's a significant quantity of cable to be manufactured. And it's a huge undertaking in terms of manufacturing and transport and the vessels involved, etc. In terms of the marine works then, I have a couple of slides here just to give an overview of some of the surveys that we've done. These are some of the survey vessels that were used in that time frame from 2014 to 2017, I think. I won't run through each of these in too much detail, but just to give the timeline, in 2014, it was really desktop studies, looking at viable routes, deciding whether to avoid UK territorial waters, etc. So high level. We then moved to geophysical surveys, where we looked at the seabed geology and looked at some of the conditions along indicative routes at that stage. 2015 and 2018, we did UXO surveys, so unexploded ordnance, and some samples were taken along the route, with some sites being cleared at that point in time. 2015 and 2018, there were benthic surveys undertaken, which was looking at some of the marine habitats along the route and looking to identify environmentally sensitive habitats. So the route that we've chosen actually that doesn't intersect any protection zones or special areas of conservation. Geotechnical surveys then were undertaken, where core samples were taken to understand the seabed itself. The route that we've gone with is consists mainly of gravel, sands, clay, silt, chalk. It's really at the landfalls then on the French side where we have rock, where we might need some HDDs, horizontal directional drills, whereas the approach to the Irish side at Claycastle and Youghal seems to be less rocky and more sediment infilled. We then had some integrated survey reports undertaken, and then other associated marine engineering studies. You see those listed on the right, but ultimately it's all led to a route that's approximately 500 kilometers in length, that avoids the UK territorial waters, avoids special protection areas. As expected, there would be variable seabed geology along a route that is almost 500 kilometers long, but there are no major constraints that we understand at the moment. There are other in-service cables that would need to be crossed, and that adds a little bit of complexity in terms of the design and the installation, etc. The water depth is in the region of a maximum of 100 to 110 meters. Moving to the onshore cable routes then, the landfall point in Ireland is at a beach known as Claycastle in Youghal. And from that point, there'll be a transition joint bay installed where the submarine cable will be jointed to the land cable. The land cable will run along the N25 and will bypass the village of Killa and Castlemartyr and move along the N25 before it heads north and northwest, avoiding the town of Middleton, before it winds its way to the converter station location, which is at Ballyadam, just by Carricktool. There is then approximately 10 kilometers of 400 kV AC cable that will run from the converter station site to an existing substation at Knockraha. On the French side, the route is approximately 40 kilometers from their landfall point. And the route approximately consists of 70% within the roadways, 30% on farmland. There's a significant crossing, let's say, in terms of a river and a railway crossing that will need to be implemented. The ground conditions on the French side, there's a lot of granite on the approach to the landfall point, and there are tough soil conditions along the route. So in terms of the current status of the project, key statutory approvals are in place. We have, as I say, submitted an investment request, and the national regulatory authorities have provided their cross-border cost allocations, etc. The technical specifications have been developed and issued to the market, as has the preliminary EPC contract, both of which are under refinement through the procurement process at the moment. And that's a significant portion of my role at this point in time, in terms of working with the bidders as they query and try and understand our specifications. And we similarly are reviewing their offers and ensuring that the offers are going to be compliant with our requirements. The ITN, the procurement itself, was launched in April 2021. And as I say, we're mid-process at the moment. Our planning application, both onshore and offshore, have been submitted, and we expect a decision in the first half of this year on the Irish side, and similarly on the French side, the applications have also been submitted. And we are planning for our final investment decision in Q3 this year. And what that means in terms of final investment decision is the award and signature of the contract to the successful bidders arising from the EPC procurement, and moving the project forward into the design and construction phase with a planned energization date of 2026. So I have one final slide just to finish on a bit of a high note. My main role in this project is the technical specifications and the ensuring that the requirements in terms of the interconnector and the connection points here in Ireland are understood and delivered by the successful contractors. So this little video that I'm going to send or share with you now does keep me awake at times a little bit, but the first part of this is the ex French ambassador here in Ireland, who was quite the advocate of the project, introducing and talking about the project at the McGill Summer School in 2018. But it's been merged with a sketch that was done by Savage Eye here in Ireland that has been doing the rounds actually recently. I've seen it come through in a couple of messages from friends poking a bit of fun at me, but I'll play it and it'll become self-apparent in itself.
And my final example will be on the very important energy project that will connect our two countries with an electric cable, 500 kilometers underwater, which will link Cork Island and Brittany from Cork to Brest by 2026. It's a major undertaking. It's a €1 billion project. It will provide electricity to 450,000 homes in Ireland. It will boost the development of renewable energy in Ireland. It's the Celtic Interconnector, which will be Ireland's physical link to the continent.
I'd like to present this plug to the head of the electricity department.
Okay, that always gives me a little bit of a panic. But yeah, hopefully you enjoyed that presentation, and I'll pass back to Siobhan maybe.